It controls every move we make. Its 14 billion cells connect a network of almost infinite complexity, which enables us to learn from the moment we're born. These tranquil folds are the busiest organ in the body, constantly providing us with insight and creativity. Probe the secrets of our mind as we explore the human brain, next on Body Atlas. I think, therefore I am. This is the home of all human thought and of our consciousness. The human brain is the pinnacle of evolution, the only object aware of its own existence. It's also the center of a complex intelligence-gathering operation that employs the clear window of the eyes, senses to pick out the sounds and sweet airs that surround us, organs of touch crowding into the sensitive folds of the lips, and every inch of the skin. They alert us to a warm wind or the chill of snow, the lightest touch or a stab of pain. These signals are routed along the body's information superhighway, the spinal cord. This bundle of delicate nerves is protected by a spiky suit of armor, the backbone. It leads upwards to the bony helmet of the skull, encasing one small organ that can encompass the whole world outside. Brian and his classmates take this jewel in their crowns for granted. Unlike the body's other organs, we can't easily feel or monitor the brain's ceaseless activity. But it's the key to human success. We've come to dominate the world not by strength or speed, but by the development of this one special organ. We can think in abstract symbols like language and math, and build up knowledge from generation to generation. The power of the brain isn't evident at first sight. Looking like an oversized walnut, it's 3 pounds of soft, watery tissue. The brain's secret lies in its billions of microscopic nerve cells. When we think, minute electrical signals flash between these nerves. It's similar to the electric currents that flow between the tiny transistors in a computer chip when it makes a calculation. But the network of nerves is far more complex. The 10 trillion connections in one brain outnumber the stars in the Milky Way 100 times over. The active nerve cells need a generous supply of energy. This network of blood vessels brings in oxygen and sugar, the brain's fuel. Over a pint of blood flows through the brain every minute. And a continuous supply of blood is essential. Nerves die rapidly when oxygen is cut off. After just a few seconds, some cells begin to shut down. We lose consciousness. After a couple of minutes, the brain suffers permanent damage. Brian's brain requires an energy supply of 10 watts, only a fraction of the computer's needs. Like the machine, his nerve center is wired into a wider network. Electrical energy constantly conveys signals along the spinal cord to and from the brain. But in close-up, nerve cells are very different from electrical wires. There are many gaps for the signals to jump, providing thousands of alternative routes. And living nerve cells can link up to their neighbors, creating yet more new pathways, unlike the programmed route of electric currents in the computer. The nervous system is one of the first parts of the body to form. Only 3 weeks after a human egg has been fertilized, some of the cells develop into a distinct swelling, which becomes the brain and spinal cord. Over the next 2 months, the nervous system develops at an amazing speed. During this time, the brain churns out 250,000 nerves every single minute. These cells move through the tissues of the body to their final destinations. Here, a new arrival is putting out feelers to connect with its neighbors. Over the first 4 months in the womb, the baby's brain produces all the nerve cells it'll ever have. At the same time, bones, highlighted in red, start to form. They protect the vulnerable network of nerves. The top of the skull is made of 8 separate bones, allowing the brain to grow inside. 5 months before birth, 14 billion brain cells are in place. Yet even at birth, vital connections between these cells are missing. Compared to other animals, the newborn human brain has a long way to go to reach its full potential. The wiring of the brain is shaped by experience, as parents and teachers pass on thousands of years of accumulated knowledge. Its expanding network of connections makes the brain grow rapidly. With signals from the eyes and ears, hands and feet, the brain begins to coordinate the young body. By repeating its successes, a child learns hand-eye coordination, the skill of balancing on 2 legs, and even something as complicated as language. By the age of 2, some children can speak 2,000 words. As we learn, we actually change the structure of the brain. All parts of the brain are connected by these bundles of nerve fibers, crisscrossing the interior like telephone lines. Each time we repeat an action or a word, the connection we're using becomes stronger. So as we achieve new knowledge and skills, we literally rewire our brains. These reconnections make humans remarkably flexible in what we can learn. It's one reason for our success as a species. The rewiring takes place within the front brain. It's the part of our brain that thinks. The front brain has reached its maximum complexity in humans after billions of years of evolution. The brain of our earliest ancestors, the fish, has only a very small front region, the fringe on the left. The main bulge deals with sight, the fish's most important sense. The front brain grew rapidly as our ancestors became amphibians. By the time reptiles evolved, it was the largest part of the brain. In a bird, the front brain has enlarged further. A bird is smarter than a reptile. In the first mammals, the growth of the front brain and intelligence continued, until in humans, the crinkled surface of the front brain seems to have taken over entirely. But hidden inside and below, we still have our ancient fishy brain carrying out its age-old functions. These nether regions of the brain keep our hearts beating and our lungs breathing. The cauliflower-shaped cerebellum keeps our bodies in balance. The human cerebellum is the most complex in the animal kingdom, possibly because it's more difficult to balance on 2 legs than on 4. This early part of the brain has a primitive beauty all its own. Without the cerebellum, we'd have to concentrate on standing upright and taking every step. From its primitive base upwards, the human brain has successive layers of intricate connections and staggering complexity. In these layers is hidden everything that makes us individuals: emotions, memories, aspirations, and thoughts. The human brain has reached its present complexity and size in only 5 million years since the human lineage split from the chimpanzee. The story of the brain's evolution is revealed by changes in the skull. A modern chimpanzee has a brain only slightly smaller than one of our possible ancestors, Australopithecus africanus, who lived 3 million years ago. 2 million years ago, a larger-brained early human emerged. These people made the first tools. Dating back 500,000 years, this human skull housed a brain twice as large as the early Australopithecus. Homo erectus had mastered the art of using fire. The human brain reached its present size 130,000 years ago. But it took another 100,000 years to reach a mental capacity similar to ours. A child from 35,000 years ago could easily learn all the skills needed to survive in present-day society.
How the cells excel.
The human characteristics that evolved then, self-expression and curiosity, are still the cornerstones of society today.
Although this, I'm going to keep cruising around here for you because this is...
The number of nerve cells in the brain has multiplied immensely over the past few million years. The brain was in danger of outgrowing the skull, but it was saved by a clever piece of geometry. The cells we use to think lie on the surface of the brain, in a layer just 1/8 of an inch thick, the cortex. And a large surface can be stuffed into a small volume by crumpling it up. Like a sheet of paper, the cortex has crumpled into fissures and grooves. If we smoothed out the crinkles, the cortex would be the size of a pillowcase. With these intricate folds, we far outdistance the thinking power of even the largest animal brain. The nerve cells in the cortex do everything that's unique to humans. To make decisions, to voice opinions, to interpret what we see and hear, and to understand it. The crumpled cortex forms 2 distinct hemispheres, each filled with bundles of nerves. The 2 halves have different ways of interpreting the world. The left hemisphere thinks in words, while the right half thinks in images and feelings. The nerves exchange information through a dense band at the base of the brain. Every point in the right hemisphere is connected to an exact mirror image point in the left hemisphere. If the word water appears here in the left hemisphere, then just here, the right hemisphere has an image of water. To prevent any argument within the brain, one hemisphere, almost always the left, makes the ultimate decisions. When it comes to controlling the muscles, each hemisphere is responsible for one side of the body, all the way from the feet and legs to the hands and eyes. But the lines of command cross over. The left side of the body is connected to the brain's right hemisphere, while sensations from the right side of your body end up in the left hemisphere. The most sensitive regions command a disproportionate number of nerve cells in the brain's feeling center, called the sensory cortex. This weird figure shows how your brain feels your body to be. Highly sensitive parts loom large in the brain's view of the body. The lips look huge because they're extremely sensitive and ideal for displaying our feelings. Children instinctively use their lips to explore the world around them. The ball stimulates the nerves in his lips, sending signals to this very specific part of the brain. A different part of the sensory cortex lights up when you touch something with your right index finger. The hand is packed with nerve endings, so we feel it to be much larger than life. The thumb is biggest of all. It can discriminate the finest details by touch. The entire back stimulates fewer nerve cells in the sensory cortex than the palm of your hand. A second figure shows how much of the brain is devoted to controlling our bodies. His largest parts have many nerve cells in charge of finely tuned muscles. The two distorted figures have much in common. Parts of the body sensitive to touch generally need the finest control. From birth, our nerves can feel sensations, but it takes time and patience to control our muscles properly. Among the first we master are the facial muscles. A baby can express emotions with a smile or a frown from a very early age. Our facial expressions acquire more finesse as our muscles and nervous system become more mature. The expressive lips need fine control to convey speech and emotions. In the brain's view, they are enormous. The hands are packed with precision muscles. The huge amount of brain devoted to the hand has been vital for our evolution from our clumsy ancestors, and it's led to some of our greatest cultural achievements.
If you want to try and look for... Actually, we do have a...
To monitor our muscles, we rely on our vigilant sense organs. Each is connected to its own region of the brain's cortex. The eyes send signals to the back of the brain, along nerves that cross over on the way. Where we see the world is strangely furthest from the eyes themselves. When you see something, electrical signals race along these pale nerve bundles. They carry coded messages through the brain's massive hemispheres to the back of the cortex. This scan shows electrical activity in the part of the brain where the messages are received. The ear keeps us in touch with every sound and with messages from our fellow human beings. Sounds are amplified and detected by a natural microphone. Its signals, more sensibly, are analyzed in a region of the brain right next to the ear. Smells are conveyed by invisible molecules to the back of the nose. They trigger nerves that fire straight into the depths of the brain, where our emotions reside. That's why smells can trigger long-lost feelings and other memories. Here, a sniff of perfume lights up several parts of the brain. The visual region at the lower right is recalling a view associated with the smell. The unconscious pathways that link our senses are still largely unexplored, and we don't understand how the cortex ties together its scattered responses to our different senses to create a seamless image of the world around us. Most things we do involve almost every part of the brain.
Tell me all the meanings of law in English.
Even something apparently as simple as answering a question.
Yes?
Or it.
We must hear the words, understand them, draw on our memories, and then voice the answer.
She? Anybody help?
Because it reinforces particular pathways through the brain, language has molded the very way we think. This area organizes our thoughts according to the rules of grammar. It sends signals to the region which coordinates our breathing, vocal cords, tongue, and lips to allow us to speak.
Conmigo.
Muy bien, perfecto. Now we're on a conjugation round.
Language helps us to learn new facts and new ideas. But we can't recall everything we were taught at high school. The brain is selective, choosing what seems to be important, and it stores information in two stages. First is short-term memory. Hear a new word, and you can recall it for a few seconds, but it will quickly fade unless it's filed in the long-term memory.
All has to be right for the point. Who shall I choose? Desesperados? Corey.
Traduzco, traduces, traduce.
To retain what you've learned, the brain must build up permanent new connections between its nerves. The actual structure of the brain changes subtly each time we commit a new fact to our long-term memory. New links are forged throughout the brain. But it's still a mystery how we can recall these dispersed memories at will.
Yours, Mr. Johnson.
With constant repetition, memories become more deeply ingrained. The brain can teach itself by repeating words and facts mentally. Remarkably, the technique also works for physical skills.
Hey, Mr. Johnson, Mrs. Johnson, yours. Sus. Perfecto.
The human brain is our most wonderful and our most mysterious organ. Scientists have yet to learn the function of every fold and crease, and how this mass of nerve cells creates intelligence, consciousness, and self-awareness. A computer that can think, let alone be aware of itself, is still far off in the realms of science fiction. Yet each one of us contains a far more powerful computer than any space-age instrument. The human brain has the ingenuity to take us to the furthest corners of the earth and beyond. Its mental reach knows no limit. With our flexible brain, we can look beyond our own world and contemplate the infinite.